Hi, my name is Frank Schröder. I work for the eBay Classifieds Group in Amsterdam, and today I want to introduce you to Fabio, fast modern HTTP router I've written in Go. So first let's start with the question, why would anybody build another HTTP router if we already have so many out there, like HA Proxy, Nginx, Apache, Netscalers, BigIP, Varnish, Squid, but also more modern ones like Traffic and Vulkan. So in order to understand why I would attempt such a thing, let's have a look at our current architecture landscape and the way we're developing software. So more and more services, especially large-scale services, are developed as a set of microservices which need a certain amount of coordination in order to function. Then we have agile development, so we want to have fast iterations. For that we have constant refactoring, where we're moving things around that used to be in one corner of the code and now they move somewhere else. We have continuous integration, delivery, we have multiple development environments, so lots of configuration that needs to be maintained. With auto-scaling, we have cost of existing hardware that we need to purchase, maintenance, so time it takes to maintain certain setups. So if we run microservices with static routing, as we did a while ago, it would probably look like something like this. So you have a firewall which has some configuration on where your instances are, and every time you add a service or you add a new instance, you would have to reconfigure the firewall. So that means that an essential part of your application sits in that firewall, and you would have to configure that and maintain the configuration. So with the registration, the service registration tools that have surfaced over the last couple of years, like Consul, etcd, but also the Mesos Marathon stuff, Zookeeper, you can take a different approach, which looks a little bit like this. So you have your firewall, which basically routes the traffic to a set of reconfigurable HTTP routers, which in general is set up using one of the standard tools that you have, like the software HTTP routers like HA Proxy, Varnish, Nginx, Apache. And then you generate a config file for these routers on the fly based on the information that you can find in the registry. So for Consul, there's a tool that you can readily use. So it watches the changes in Consul, then generates the configuration file based on some template, and then you then you restart or reload the service. And in order to make this really a zero downtime restart, you have to, at least with HA Proxy, you have to jump through all kinds of hoops. So you have to use some IP tables magic, or you have to hand off sockets to an existing process in order to make this work. So there is a long blog post from Yelp Engineering, which explains in gory detail on how to make this all really zero downtime. So, but in essence, what you have again is that vital configuration sits somewhere outside of your application. In this case, it sits in the Consul template configuration, which then knows how to generate your service, your router configuration. So in essence, the services already know which routes they accept because you have to write handlers for them. So if you have a service which accepts traffic for /foo, it needs to have a handler. Well, I mean, you can write in a different way if you have URL rewriting, but if you have a service which accepts traffic for /foo, you can write a handler for /foo. So it knows that it can handle /foo. So why don't we just push the routes into the service registry? And that's in essence the main idea that Fabio is exploiting. So we just turn this around, and the services, when they register, they publish their routes, the routes that they're accepting, into Consul, and then Fabio can just be the proxy that updates its routing table internally and just swaps it out atomically. So that means you have a service that's constantly in an HTTP reverse proxy, and it's just updating its lookup table every time Consul changes, and it can do that in process without taking listeners down, without restarting the service. So there's a challenge with this. So the problem with, at least with Consul, is that you can when you register a service, you register it with a host port and a health check, but there is not really a convenient place to put metadata along with the service registration. So where would we store the /foo or the my.com /foo information? So console comes with a KV store, a key value store, where you could store these kind of things, and then that looks like kind of the obvious choice for doing this. But if you think about it, then you would have to perform two operations every time you register a service. So for one, you would have to register the service, and then you would have to either add or update an existing entry in a routing table. And you would also have to have some kind of naming scheme and namespacing in order to manage all these routes. So you wouldn't have any atomic update with the service registration because you register the service, but then the KV update fails. Or in any other combination. So you would also have a more difficult integration with third-party tools like the registrator, so they would have to know this kind of scheme. What would happen when you kill -9 the service and it doesn't manage to clean up the KV stores? You would have to have some kind of cleanup process, and this introduces all kinds of race conditions. So service registration allows for tags, and we can use this as a kind of workaround in order to encode metadata, at least this kind of metadata, into the service registration, and then we get our atomic update. And it also plays nicely with tools that already register a service in console, because in general they have also an option to add additional tags. So now all you have to do is, when you register the service, you also have to add all the routes, including the hosts, if necessary, to the service registration, start Fabio, and then you're done. So what does this look like? So Fabio watches the routing table, or watches the healthy services in console, and every time that information changes, it rebuilds the routing table and pre-computes it in memory, including all the round robin and the weighted round robin distribution, and then swaps it out atomically. So if you have an automatically generated routing table, then of course that would require that you need to do a service deployment every time you want to make a change or you want to fix a bug, because of course we'll make mistakes. But Fabio allows you to have manual overrides, so you can add additional entries to the routing table to the console KV store, which Fabio will also monitor. So as soon as you make a change there, it will append it to the automatically generated routing table, and then this will be the combination, will be the final routing table for your services. You can also have multiple prefixes for service, which comes in very handy if you want to move an endpoint from one service to another. So you can have both the old and the new version running next to each other, and this is actually something that we're using to rewriting one of our Java services to Go. So they both offer the same HTTP endpoint, implement the same protocol, but they're just completely different services. So we can slowly migrate things from the old to the new service, and even use dynamic traffic shaping for this by making sure that the new service only gets a certain amount of traffic. The traffic shaping also, at least the way it's implemented in Fabio, has also one additional nice property in the sense that it's completely independent of the number of service instances that you're running. So if you decide that you want to send 5% of traffic to the new version of your service, you can do that independent of whether you're running 1 or 10 instances. Fabio will do the math for you, and you don't have to do any of the weight calculations. Fabio has been written in Go 1.5. It's mainly the core logic is really just a reverse proxy with a very simple handler, and most of the logic is in managing the config information, so updating the routing table and swapping it out. It has currently right 1900 lines of code. It has been in production since September 2015. I've had it developed for about 6 months. It currently runs all of Marktplaats, which is like the largest site in one of the largest sites in the Netherlands, with about 8,000 requests per second. Parts of Kijiji, Italy, with another 500 requests per second, and in a couple of weeks also my own platform with about 5,000 requests per second. That's about it. Thank you very much. Have a look, check it out, and here's my email address and Twitter account. Bye bye.